Hi, so today's vodcast is all about tides. And in order to really understand how tides work, it's important to talk about Newton's universal law of gravitation, which essentially states that the force of gravity is inversely proportional to how far objects are from each other. And d in this case represents distance. So to really kind of solidify this idea, it might be helpful to actually plug in some numbers for d. So let's say two objects are 5 meters or 5 inches apart. So that's a force of gravity of 1/25. But if you double that distance, make it a greater distance, then that's a force of gravity of 1/100. So this demonstrates that force of gravity is inversely proportional to the distance. When the distance is increased, the force of gravity decreases. So again, they are inversely proportional. And this helps us to understand how tides work. So if this body right here is the Earth, and we have the moon right here, the moon is going to exert a gravitational pull on the Earth. And as we just figured out, the closer these objects are together, so like right here, is when the force of gravity is the strongest because it's the smallest distance. But then as you get farther apart, the force of gravity exerted by the moon weakens because the distance is decreasing. So this helps us understand tides. So let's just say the hydrosphere, there's just water around the Earth like this. When you have this huge gravitational pull from the moon right here, it's really going to cause this water to bulge out. And that creates a high tide. And you're probably wondering what happens on the other side. And essentially, if you think of the concept of a basketball or a soccer ball, when you compress it, it's not just one side that's bulging out, it's going to be both. So the high tide is going to also occur on this side of the Earth as well. So you have a high tide here, then low and low. And again, this is all because of, Newton's law of gravitation and essentially the gravitational pull exerted by the moon on the Earth. So there's two types of tides. There's a tide called a spring tide. And we are going to bring another object or planet into this situation, which is the sun. And the sun is massive. And you would think that it would have a huge impact on the Earth and the tides, specifically, not the Earth, the tides. But it does have an impact, but it is at least half that of the moon, just because it's so far from the Earth. So a spring tide occurs in either the full moon or the new moon stage, or phase of the moon. And in essence, this is when the high tides are the highest and the low tides are the lowest. Why is that? Well, as we explained earlier, the moon's gravitational pull is going to be greatest right here. But because the sun, moon, and Earth are all in line, not only do you have the moon's gravitational pull pulling this water, the tides this way, you also have the sun's gravitational pull. So it's just extremely strong, and this then creates like the highest high tide and the lowest low tide. And again, this occurs either during the full moon or the new moon stage. So again, all three bodies are in line. And the other type of tide is called a neap tide. Again, you have the sun here. And you have the Earth here. And the moon can either be in the first quarter stage or the third quarter stage. And this is going to be a lot different than the spring tide. And it's not going to be the highest high and the lowest low because The moon and the sun are going to be at a 90-degree perpendicular angle. So unlike the spring tide, they're not all in line. And the moon is kind of pulling and the sun is also pulling. So it's not really pulling the tides one way clearly, and it's not creating a super intense high tide or low tide. Again, because they're not all in line. You have the moon up here and the sun here. And so it kind of creates a slightly higher low tide, but like a much less dramatic shape of the tides on the Earth. This is in the first quarter and the third quarter when the sun, moon, and Earth are not all in line. You have these different gravitational pulls. So that's the neap tide. And if you're wondering why we have two high tides and two low tides, in essence, the Earth revolves. It's a full revolution in 24 hours. And in that process, I'm going to use this example, you'll have the high tides, and it'll take about 12 hours to have a pair of tides, like a high tide and a low tide. And then to revolve again to another high tide and a low tide, it'll take another 12 hours. So it takes one revolution to go through two high tides and two low tides. So that's essentially why we have two high tides and two low tides every 24 hours, or approximately 25 hours. So yeah, this all goes back to the force of gravity and how it's inversely proportional to the distance between two objects. Thank you so much.